So this is one of our elevator problems. So in this one, we have a 75.5 kilogram person. So their mass is 75.5 kg. Okay, they're standing on a scale on the elevator. And as the elevator starts upwards, that elevator scale is going to read 995. So again, we're calling this that scale reading. What it's really telling you is how much force is the elevator pushing up on the person with. Is 995 newtons. And then as the elevator comes to a stop, it tells us that the scale reading goes down to, instead of 995, it goes down to 620 newtons. So our whole idea is how fast does the elevator accelerate? It starts to go up, and how quickly is it slowing down at its desired floor? So the idea here again is we want to find acceleration. Well, acceleration equals F net over m. But that 995, that push from the elevator, is not the only force on that person, because while the earth is also pulling down on that person, and it's pulling down on that person with its weight, and the weight of that person is equal to, so F sub g is equal to m times g. So we're going to take that 75.5 kilograms and make it 755 newtons. Okay. And over here, that person on the way when they're stopping also has a weight of 755 newtons because, well, the Earth's pull on that person has not changed. Their mass hasn't changed. They're still the same person. So A equals F net over m for both of these two. The question is, what is F net? Well, on the way up, it's going to be this 995 up, 755 down. You add those two together, since they're opposite signs, F net is going to be the 240 newton difference between the two. And that's acting on that mass of 75.5 kilograms. Okay. When they get up to the top, the F net again is going to be the difference between the two. Now, though, it's mostly downwards. Okay. And it's going to be 135 newtons. So we're going to make this a negative 135 newtons over 75.5 kilograms. So if we do the math really quick with that, we'll see that 240 divided by 75.5 is 3.2 meters per second squared at the start. And at the finish, we do 135 divided by 75.5. We'll see that it's 1.8. Negative 1.8 meters per second squared. Because again, our acceleration there is happening in the downwards direction. So again, we're dealing with things lifting going up or stopping as they're going up, trying to slow them down. The big thing is we need to have not just the force that's being exerted, but we need to account for the fact that gravity is always pulling down on that object. The Earth is always working on that object, moving it towards the center of the Earth.